Hi coders, today we are going to discuss problem number 33 on LeetCode. In the previous video in this playlist, we have seen how to search for a target element in a sorted array. But there is a slight modification here. The array nums is not only sorted, but it also can be possibly rotated. The aim of the problem is to write the algorithm in log n time complexity. We know that we can apply binary search on a monotonically increasing or decreasing array to search for a target element in the array. If we forget about the rotation for a moment, the given array is sorted in increasing order and only contains unique elements. So we can conclude that the given sorted array before rotation was strictly monotonically increasing. But the question arises is, what would happen when we rotate this sorted array? I have listed some scenarios over here. This is the case when the array is not rotated. Here the 0th index lies to the left of the middle element after rotation. The middle element that I am referring is the element indexed at low plus high by 2, where low points to the 0th index and high points to the last index of the array. In this case, the 0th index lies at the middle index after rotation. Here the 0th index lies to the right of the middle element after rotation. If you notice that in all these 4 scenarios, there would be at least one half that would be strictly increasing. In this scenario, both the halves are strictly increasing. Here the second half, here also the second half, and here the first half. Keeping this observation in mind, let's see if we can reduce the search space by say a factor k in subsequent steps, which would result in a time complexity of log n base k, where n is the range size and k is the factor. We just concluded in the previous slide that one half of the search range would be sorted. And if the target lies in that half's range, we can choose that half and apply binary search, and the problem reduces to searching for a target element in a sorted array. And if the target does not lie in that half's range, we can choose the other half, which can be possibly rotated. So we are basically reducing the search range by a factor of 2 in every step. So the time complexity would be log n base 2. As I mentioned earlier, n would be the search range size, which is here equal to the size of the array. Let's see how we'll implement this using template 1. We have initialized the low to the 0th index and high to the last index of the array. If we find the target at the middle element, we can return mid. The control will go into this else if block if the left half is sorted, and it will come here if the right half is sorted. So here if the left half is sorted and the target lies in the range, we can reduce the search space to the left half. Else we can move the search space to the right half. Similarly, here the right half is sorted, and if the target lies in the right half, we shift the search range to the right, else we'll shift the search range to the left. By default we return -1 if we did not find the target element in the array. Let's try to dry run our code now. Initially low is equal to the 0th index of the array and high is equal to the last index of the array, that is 6 here. Mid is initially equal to low plus high by 2, that is 0 plus 6 by 2, which is 3. The value at mid, 6, is greater than 3. So the left half is sorted. We see if the target, that is 2, lies in that half. Since it does not lie in that half, we'll choose the right half and we'll shift our search range to the right of the mid. We'll come outside again. We'll recalculate the mid element. Low is 4 and high is 6, so the mid would be 5. Since the value of the mid element is 1 and is not equal to 2, we go to the else if block. Since the middle element 1 is not greater than equal to 7, the left half is not sorted, we go to the right half. We check if the target lies in the right half range, that is 1 to 2. Since the target is 2 and it lies in that range, we update our low pointer to mid plus 1. We go out for another iteration here. We'll update a mid pointer, which would be equal to 6. Since 6 plus 6 by 2 is equal to 6. We'll check if the mid value is equal to the target. Here 2 is equal to 2. So we have found the index at which the target element is located. So we'll return 6 here, which is the answer. If we think about the time complexity here, it would be log n base 2, as we discussed previously. And the space complexity would be O1. Because we are not using any additional space, And since it's an iterative binary search, we're not using recursion stack. That's all for this video. Thanks for watching the video till the end.